So on Thursday, I told you the overview, right? We're gonna start with triangles, classifying them, naming them. Everything about triangles is still true. We know how to solve them. Sine law, cosine law, right? We know all those things. We know Pythagorean theorem. And then we're gonna move over to quadrilaterals. And then last is gonna be polygons. But really, polygons encompasses everything. Every shape is under the polygon category, but we have specific names for these two. And then we went over the Pythagorean theorem, right? If you want the hypotenuse, you got to add the squares of the legs. If you want the leg, you got to go hypotenuse squared minus leg squared. No big deal. It only works with 90-degree or right triangles. No news there. We practiced a couple. Then we went all the way over to page 179. And I want you to go there real quick. And so I asked you to write down classifying triangles on the top. And always know that the interior angles add up to 180. And I want you to have like if you go and classify by angles, you have acute, you have right, and you have obtuse. This should probably make its way onto your study sheet. And then side length. This is on page 179 in case you're wondering. You have equilateral. You have isosceles. Or you have the one that's the most common, really, but not the word, you don't use it very often, is the scalene. Okay, so this is your first name, and this is the last name of a triangle, right? I don't really care if you flip the order, to be honest, but you just need to have any combination of two, right? Except for equilateral. If you just write down equilateral, that's it. It will always be acute because all angles are always 60 degrees when it comes to equilateral. Good? And we talked about that, and that's what tomorrow's AC is going to be about. It's like classifying and naming them. And so next page here. We went over that, the last names, and we briefly went over this example. I went over symmetric versus asymmetric. You basically cut this in half, the base, but if it's asymmetric, you cannot assume that you're cutting it in half. Okay, keep going. Just a quick run through to get you ready for the next example. And so on page 181, which is a blank page, I asked you to classify the following. I'm going to give you another 6 to try, okay, right now. So I hope you have room at the bottom of that page. You should be on 181 here. And so I'm just going to cut that page in half like that. And I'm going to say classify. Okay, so A. This scenario, we're going to go A, B, C, 50 degrees, 40 degrees. This is on page 181. Just copy this down, and then you're going to have to classify it. B, we're going to have one of those. It's 40. And we're going to go D, E, F. D, E, F. That's a 40-degree angle up here, by the way. And C. And you cannot go by the diagram, you go by the information that I give you. So that's a 45. These two sides are the same. And then leave a little bit of room between so you can name them. And so D looks like this. E. And I'm just assigning random letters to the corners. Okay, give them all a name and a last name. So this is basically tomorrow's AC, part of tomorrow's AC. Okay, so I'm going to grab a different color just to make sure that the things that I added are new, like are visible. So remember, this is what I want you to always keep in mind, right? Sum of angles in a triangle is always equal to 180. So 50 and 40 is 90. So this must be 90 as well here. And in fact, you can make that little box there. So this is, when it comes to angle measure, it's a right. And because all three angles are the same, what do we know about all three sides? Crickets. They're all different as well. Okay, did I say same? Oh, sorry. All three angles are different, therefore all three sides are different, guaranteed. Okay, so this is a scalene. Okay, next up, watch this. I know that these two sides are the same, but I focus on if there's a 40 across this side, there has to be a 40 across this side, right? And so if you have a 40 and a 40, that's 80. So this must be 100. And that's bigger than 90. So then this gets into the obtuse category for angles. And because two sides are the same, this is an isosceles. Okay, next, 45, 45. So there's a 45 there, meaning that this will be 45 as well. And so that's 90, so this must be 90 as well. So this is actually a right isosceles. Okay. So far so good. 120 and 30 is 150. So this must be 30. Me knowing that these two side angles will be the same tells me that the side lengths across them are also the same. So when it comes to angle measure, it's obtuse. When it comes to side length, it's isosceles. It's an obtuse isosceles. Does that make sense? I'm walking you through it, right? So if 2.5, right, these two sides are the same, so you can actually also do this. If you have a 60 across this side, and this is the same measure as that, then you can bet that this is going to be a 60 here as well. Guaranteed. Okay? And then if you have 60, 60, that's 120 already. This must be 60 as well. So it's now, this has entered from isosceles. Knowing that all three are 60, then you can be guaranteed that this is also going to be 2.5 here. In fact, all three sides are the same. So this is just equilateral. That's it. No need to put acute equilateral. It's not wrong, but that's what that is. Last one. All three sides. Watch what I'm going to do here. I'm just going to make a note that all three sides are different. So it's scalene when it comes to sides. It's obtuse because of this. Scaling. Sometimes I'm going to ask you to actually calculate it. In this case, you could have just gone by the diagram. Okay. So there you have it. That's how you. For C. This is 45. This here, this is a 40. $50 and 40 is 90. Yeah. So these add up to 90, so that 90 and 90 is 180, right? Make sense? Okay. So this is basically what the first chunk of the AC will be, stuff like this. All right, let's keep going. We already went through 182, so I'm not going to go over that again. Okay, I walked you through that. We did the roof question as well on the back side here. And we classified within the triangle. They asked us to classify each of the sides as well as the whole roof. And so we named them all. They were all scalene, but two of them were right, one of them was an obtuse. Okay, so you have that there. Let's keep going to 184. And this is where I'm going to let you go a little bit for 5 minutes, maybe a bit longer. I never assume you know, so I want to make sure. Do you know what perimeter is? Distance, yeah, distance around shape. That's one way of looking at it, right? Sum of sides, right? If you want to add up all the sides, that's also perimeter. So it's very important to know that before you enter this question, because this is going to give you some hints as to what you can fill into this diagram. Okay. The area of this triangle, they remind you what the formula is of it's base times height divided by 2. So you can use Pythagorean theorem, you can use a bunch of different ways of doing this question. Read it carefully, try to figure out what goes where and how you would solve that. Okay, so 5 to 8 minutes and then I'll go over it, but don't wait for me. It's okay for you to erase. There's lots of room. There's way more room than what you're going to need for this question. I can guarantee you that. Let's see how you did. Breakdown. Okay, so the perimeter, this is 30 and this is 30, but you could technically just say, right, take away, and then you're left with 30 centimeters because you use these two sides, take it away from the total perimeter. So this must be 30 centimeters, right? In fact, you can now go ahead and say this and this and this, like all three sides are the same. Classify by side length and angle. So this would be triangle X, Y, Z is equilateral, right? That's it. So I'm sure that most of you concluded that, right? The area of the triangle, well, my method here is going to be, this is a symmetrical shape, okay? Meaning that you're cutting to get the base here. You're just going to divide that in half, right? That gives you 15 centimeters, and this is still 30. That's this side here. And this is my height, so to speak. I want the height. I need the height of the triangle, right? I need this length here to find the area. So height is Pythagorean theorem, right? Take the hypotenuse, subtract one of the legs from it. You get, what is it, 675? And the height is 25.9808. And you're probably wondering why 4 decimals? Because I'm not done yet. That's what I'm doing now. So I'm just saying, okay, my height, I know what it is, but that's not what the question is asking. It's asking for area. Area is base times height divided by 2. Now, what's the base of the triangle I'm trying to find the area for? It's 30, okay? Not 15, because this is just cut in half, so I could find the height. So it's 30 times 25.9808 divided by 2. So that's 389.71. And if you didn't round to 4 decimals, you probably got 389.70 or something like that. So it's not the biggest deal, but this is technically how you would do it. 4 decimals along the way, 2 decimals at the end. Okay. How would you, if you had to classify this one, it would be a right scalene, right? All 3 sides are different. So is cutting an equilateral always going to be a right scalene? Well, you would have to always check and make sure. Okay, so that's this question. Moving on. The top half here on 185 is there for you to fill in the following question. Which ramp be the easiest to push a wheelbarrow? A cart, let's just call it a cart. Let me just go look that up. Scalene. Isosceles. which one of these ramps would be easiest to push a cart over? And it has to be both ways, not just one way. Which one would you say is the best? Matthew? Scalene, you would say this one is the best? Coming both ways? Because if it's scalene, this it would be hard going up here and then easy going down, right? And it would be a long ways up, and then it would be quick going down. You would say isosceles? Why would you say isosceles?
If the bottom, like the bottom one can be longer, so it could be less steep.
You could make it like this, right?
Yeah.
Yeah. So equilateral, it has to be a 60-degree, right? It all has to be 60. So this is not a good option because it would be, no matter what you do, it would be the steep, the angle of inclination, angle of elevation is always the same. Angle of elevation, always the same. Okay, you can't change that. The problem with this one is one of these angles would be steeper than the other. Would you agree with that, right? Like whatever changes you make, one would be steeper than the other. So it'd be harder going over one way than the other. So this is the winner. Okay. Base angles can be very small. You could technically, let's stretch this a little bit. You could technically have a 1-degree angle on both sides and just make it really, really easy to go up on both sides, right? Like you could make it so flat that you would almost not notice it, right? As long as you make it long enough, right? So it's the angle that that you're after, the angle right here and there, okay? So just to get you to think about 7. And again, this question is one, yeah, go ahead. This is one of those questions. This one was actually on an old provincial exam. Not exactly like this, but the same idea. Okay. See if you can, remember I was always going to pause it, let you do a little bit, and then take it back. I want you to try this, but I'm going to give you some hints. Look up and be careful here. See this marking, right? It's saying that this is the same as that. So these markings are saying all of these trusses for this bridge all have the same length. And then these markings down along the bottom is telling you that, right, this stretch is the same as this stretch, is the same as that stretch, right? So all along the bridge, the bottom of the bridge, it's always the same, okay? And you have a bunch of measurements here, and that's, by the way, that's in feet. 1 is feet, 2 markings is inches. I don't know if you remember that. So I want you to answer A, B, and C. How long is the bridge? Calculate the interior angles of triangle ABC, and then classify those triangles that are mentioned here. Go ahead. You too? Oh, you have a question? You want to ask in front of the whole class, or just, you're good? Okay. I'll come over in a bit. So give this one a try. It's quite, you need to be cutting and trying different things, but you can do it. Okay? So here we go. Some of you just need to look carefully, right? Like this number right here, right? It's right there, transferred in, right? So how long is the bridge? My approach, even if you've done this, pay attention anyways, okay? 11.3, the 8 here comes in there. And so basically I'm going to find this little stretch from here to here, which I call x. Because then I can just multiply it by 6 to get the length of the whole bridge. I realize that this is one of my legs, right? So it's 11.3 squared minus 8 squared, square root of. It's nice to have my key in front. That's 63.69, and then it's x 7.9806. And why am I using 4? Because that's not really the answer they're looking for yet. To find the length, I will go 6 times 7.9806. And that gives me 47.88. Now you can round to 2 decimals. You read it off your calculator, and this is the length thereafter. I saw quite a few of like actually the work going towards it. Great. Okay, so that's why I started with Pythagorean theorem, because you're going to use it, right? Quite a bit. And then calculate interior angles of ABC. So let's go back up. ABC is ABC, so it's actually this whole thing, like this, A, B, and C. Okay, what do we know about it? Well, we know that this is 11.3 and this is 11.3, correct? We know that across here is 2 times 7.9. Does that make sense? 2 times this, because it's technically x is one section, right? So this times 2 is going to be that, which is 15.96. And you're like, how come you're not using 4 decimals? Sure, I can, but then I have to redo it. So I won't do it right now because you get the picture. You can use cosine law. Okay, you know that these two are the same, therefore these two angles will be the same. So as soon as you find this angle, you can find B and C. Does that make sense? Do you remember sine law, cosine law? You remember that, right? Oh yeah, we just wrote that test, right? So here we go. Cosine of A is 11.3 squared. 11.3 squared. Somebody used sine law. Was it you, Matthew? You used sine law for this, right? He used sine law. What he did is he cut it and then just made this 90 and used this pair. It's okay to do that. I'm going to go minus 2 times 11. No, sorry. Do you know what you're doing, Mr. Dirksen? I hope so. Okay. 2 times 11.3. If you use sine law in any other method, don't erase. You're okay. Okay. So here we have that, and I'm just going to quickly run that through. That is 0.6584. At the top and bottom is 2 times 11.3. And when you get that, angle A is going to be cosine inverse of this, and this is a really small number. Look at how small this is, right? Let's find the inverse of that. 89.85. If we round it to a whole number, what would that be? 90, right? Because that 8 bumps that to a 10, which bumps that to a 9. Whole number. Okay? How about this? Because I'm so always telling you to round to 2 decimals, I will have the 89.85 here, And some of you got probably even closer to 90, right? So regardless, you will round to 90. Now pay attention because this is a bit crowded here. If this is 90, I know that these two are the same. What would I do? To get angle B, I would just go 180 minus the 90, and I would split that in half. But you just got to make sure you do this, okay? Angle B is 90 divided by 2, which is 45, and so is angle C, right? They're both 45. And now I can classify ABC. So triangle ABC, it's a right isosceles. And triangle ABD is a, no, sorry, I got that wrong, right? Stop me. You got to stop me when I'm off here. So ABC is obvious. This guy is a 90, so it is a right, and it is an isosceles. Okay, we're good. Now ABD, I got to go back to the diagram. ABD is also a right, but in this case, it's what? Scalene. Because if you focus on ABD, I will highlight this orange. Right, ABD is right there. It's a right triangle, but all three sides are different, right? This is 11.38 and this is 7.988, right? And so forth. All right. Anybody write down right isosceles as well? There's a rounding. There's a rounding problem here. If we had rounded this to a whole number, this would have actually turned into an 8. So then this is 8 and this is 8. So it's a isosceles. So I will be clear on that on a quiz test or AC. Let's go over to the, we're not going to do that one, 186, the door and the cube at the bottom. Might be a good bonus question. Let's keep going. Before you go, we'll try 187 to 188. I know it's almost time. We have what, 8 minutes left. How about you do the first page at least? Do a couple of questions on page 187. And then you can slowly pack up once you've done a couple of questions. Even just the classifying, even the first 3. You might be surprised how much that will help you for tomorrow.